All right, now that we've performed our file preparation, the minimum flexible set, inverse alanine scanning, and our combinatorial search, it's now time to do minimization in the K-star-based mutational scan. So I'm just right where we left off. I'm in the directory that has my inverse alanine scanning output files from the K-star algorithm. So I'm going to go into the combinatorial search directory. These are all the files we prepared. So now that I'm in this directory, I'm going to look at the submit.out that has all the K-star scores. These are here. I'm going to copy them over to the Excel file and look at them there. So I'm back in our Excel file. I'm going to copy and paste in that data from the submit.out. Data, text to columns, again, delimiting by comma. These are comma-separated variables. Finish. And now we want to find which sequence from our combinatorial search gave us the greatest increase in the K-star score. So I'm just going to write a little column here called wild type difference and use the max function. So it looks like our max is 16.01, which is right here, this sequence. So the difference between the best combination of mutations, here 16, our wild type is going to be the row with all lowercase, which is this top column. So this top row, enter. So we've increased our K-star score by 3.2 relative to the wild type. So 12.7, 16.01. So now that we have that information, let's find this PDB file in our ensemble output and perform minimization. So again, I'm in the output directory for the combinatorial search. I'm going to go into the ensemble directory where I saved everything, and these are pictured here. And we're going to find that PDB file that has the mutants isoleucine to arginine, serine to histidine, leucine to tryptophan, and then these two residues are flexible. So let me click over and find that. And that file is right here. We can see we have 48 isoleucine to arginine, 49 serine to histidine, 50 leucine to tryptophan, and then our two flexible residues. So let's move this file out. Arginine, serine to histidine, leucine to tryptophan, and you want that PDB file. Let's just move this up the directory. And let's rename this alanine combinatorial search.pdb. It's a little bit easier to work with. So all I'm doing is I'm just moving this alanine combinatorial search into the DexDesign original folder. And I'm going to make a new directory called minimization. Again, same formatting as in previous runs, do two ensemble subdirectories. You can organize these however you like. That's just my preferred method. I'm going to move that alanine PDB file into the minimization folder. So we now have that in the folder. So it's now time to prepare this and run the minimization. I've started the interface, and this is a PDB file. So we're going to hit File, Import PDB. Navigate to that minimization directory, and that file is going to be right here. We're going to click Open, and that structural file should appear. So we're going to go through very similarly to what we have done in the past. Check the chirality. We have chain A is again our D-peptide. And again, these should all be correct. We're going to check again, duplicate atoms, missing atoms. Good, no missing atoms as expected. Going to recheck our bonds just to be sure. Bonds automatically. Protonation, clearing all hydrogens, and then having them reinserted. And then now what's slightly different, we're going to hit prepare again. Typically now we would export this PDB, and we're going to go down to minimize. And this is the menu for minimization. So we have chain Y, chain A. We want to minimize our D-peptide. So let's uncheck our protein, which is chain Y. And we have our number of steps here. I'm just going to leave it at default for the demonstration, which is 100. Hit minimize selected molecules. And you'll notice that this positioning changed in the visualization. So I'm going to close this menu. Then I'm now going to hit export PDB. I'll save this as combinatorial minimized. I'm also going to save again that OSPREY molecule as well. I'm just going to call this as well, combinatorial minimized. File and close. So now that I've done that, I'm going to locate that output PDB file in my DexDesign directory. I'm going to be in minimization. So this file here, come to our minimize PDB. I'm going to open that up in PyMol. I'm going to find any remaining steric clashes and run the K-star algorithm. So I've opened up that PDB in PyMol here. And notice we haven't run the K-star algorithm yet, so we still only have one structure. And we're going to do what we've done in the past. We're going to hit sequence here on the bottom right, the S. Visualize side chains. Put our D-peptide in different colors so it's easier to see. Extract it. And we're going to use our plugin once more in order to visualize these steric clashes. So we're again going to go over to our dots group, and let's uncheck these favorable and look at any remaining steric clashes. So we are still clashing with H301, H311. You have some clashes in here. This is L348. This is L291 and G290. So I'm going to go over to the interface, set up a new design, and I'm going to set these residues on the protein as flexible while translating and rotating the ligand. So quick review, again, we're going to hit File, New Conformation Space. We have our OSPREY molecule ready for minimization. We're going to hit Open, Edit. I'm going to load in both of my conformation libraries. So A is going to be the D-peptide again. Chain Y is the L protein. Skip mutations, I'm going to go right to flexibility, and I'm going to look at those residues I had flexible, setting translation and rotation on the peptide, going over the protein, and I'm going to insert all of those flexible residues in the flexible positions menu. All right, so I've inserted all those residues that were clashing according to the protein design plugin. I have translation and rotation on my D-peptide. I'm going to, again, File, save the conformation space. For the complex, I'll just call this min complex. Going to split, save the peptide first. So min ligand, min protein, and then I'm going to compile the complex and then also compile the ligand and the protein as well. And then I'm going to run the K-star algorithm. So just as before, I'm in the cluster. I'm going to run OSPREY K-star scores, and I'm passing the minimized complex, the minimized protein, and the minimized ligand. So I've allocated resources. I'm going to run this and then obtain the output PDB and K-star score data. So the K-star algorithm has finished. I'm going to change over to that minimization directory. Look at that output, which is here. I'm just going to save that in my Excel file for reference. I also have a spot here if I want to log which residues I set as flexible. And note that we've increased our K-star score from 16 to 20.3, which is a notable difference. And now we want to move on to K-star based mutational scanning using the minimization structure as input for round 1.